welcome ulit sa ating YouTube channel. Ito na yung lesson 20 sa ating set theory. This is all about division algorithm and more theorems about divisibility. So, yung theorem about divisibility dito, hindi ko na ipoprove since baka isama ko siya sa problem set, saka medyo madali lang siya. Okay, so let's have theorem number 4. So, let A, B, C, and D element ng integers. Then, ito nasabi ko na to, yung remark last time, na A divides 0 or any number, 0 is always divisible by any number. Then 1 divides A and A divides A. Okay, so nabanggit ko na yan. Next is number 2. If A divides 1, if and only if A is equal to positive or negative 1. So, tama naman yun. Kung positive 1 yan, so 1 divides 1, negative 1 divides 1. Okay, then number 3, if A divides B and B divides A, if and only if A is equal to positive and negative B. So, tama naman yan. Palitan niya lang yung A ng positive or negative B, similar dun sa kabila. Okay, then number 4, if A divides B and C divides D, then yung product nila, so that AC divides BD. So, mas madali yan, I think, mas may kita. Then number 5, if A divides B and B is non-zero, then absolute value of A is less than or equals to absolute value of B. So, imagine mo na lang ano itsura nung mga property na yan o ng theorem na yan. Okay, so yung highlight talaga ng topic natin today is the division algorithm or the theorem 5. So, division algorithm, for any two integers A and B, for B is greater than 0, there exists a unique Q and R such that B is equal to AQ plus R, where 0 is less than or equal to R and A. So, this is the division algorithm. So, ano lang sabi niya? So, sa dalawang integers, may mag-exist such that dapat mas malaki yung B sa A. Dapat ganito rin yun. So, unang mga criteria na ito, dapat si A is less than or equal sa B. Okay, dapat yan yung mga isa sa criteria. And B is greater than 0, obviously. So, although pwede naman siya mag-negative. Okay, then sabi nga, there exists a unique Q and R such that B is equal to AQ plus R. This Q is the quotient and R is the remainder. Okay, so again pag may dalawang number na pinagdi-divide or kunyari quotient ng dalawang number o dalawang integer, ang ibig sabihin lang yan, by division algorithm, kaya natin sila i-represent by into which B is equal to AQ plus R. So, tulad nito, kunyari meron kang B, so parang ito lang yan, kunyari meron akong B over A, so this implies that B is equal to AQ plus R, where 0 is less than or equal to R, less than or equal to A. Then, dadagdagan ko konti ng corollary para maiwasan ko na yung mga negative. Sabi niya, for any integers A and B with A is not equal to 0, then there exists a unique integer Q and R such that B is equal to AQ plus R, where 0 is less than or equal to R, less than absolute value of A. So, nirevise lang niya to, si A inirestrict niya na hindi na mag-0, kasi nga anong nangyayari, possible na mag-0 to, yung sa ilalim. Okay, so pag nag-0 yung nag-undefined, so hindi gumagana yung division algorithm, kaya nagkaroon ng corollary. Tapos, ang ginawa niya pa, yung remainder is less than sa absolute value of A. So, meaning, kung negative yung A, ina-absolute value mo pa. So, para mas sure at tumama na yung ating division algorithm. Okay, so now illustration. So, we need to use division algorithm to illustrate the following or to define the following. So, dito kailangan natin ng calculator. So, una, yung 81 over 7. So, obviously, 81 yung B. Tapos, yung 7 yung A. Okay, so ano mga unang gagawin? Ang unang gagawin, by division algorithm, so ulit ko ito yung A, ito yung B. So, by division algorithm, this is 81 is equal to 7 times something. Okay, so paano gagawin dyan? So, punta sa calcu, gawin ko 81 divided by 7. Okay, so 81 divided by 7 is 11 point something. So, ang kukunin ko yung 11 lang. So, ang gagawin ko, kukunin ko lang yung 11. So, lalagay ko yung 11. Okay, then ang gagawin ko, so 7 times 11. So 7 times 11 is 11. So minus 81. So may 4. So ibig sabihin may plus akong 4 dito. So yung kulang para maging 81 siya is 4. Where, sundin natin to, 0 is less than or equal to r less than a. So 0 is less than or equal to 4 kasi yun yung remainder natin. Less than or equal to a. What is a? 7. O since hindi natin kailangan lagyan ng absolute value. Okay, so therefore, ano yung Q dito? Ito yung sagot. Q is 11 or is 4. Pero ito yung sagot syempre. Okay, so next is, what if we have 81 and negative 7? So, ganun ulit. Lagay ko dito yung 81. Okay, lagay ko dito yung negative 7. So, ano dapat gawin? Since ang goal natin is maging positive, so dapat negative 7 times, I think, negative 11 din. Kasi pwede naman quotient is negative. So, this is negative 11. Okay, then plus 4 pa rin. Okay, then 0 is less than or equal sa 4. Less than or equal sa absolute value of negative 7. Since yung A natin is negative 7 na. So, ginagamit ko na to, yung corollary. So, ibabox ko lang yan. So, ito yung magiging sagot. Ito yung kanyang division algorithm. Okay, where Q, what is Q? So, in this case, Q is negative 11 or is 4 pa rin. So, napansin mo, no? May effect yung negative number na yun. Okay, next is, what if we have negative 81 is equal to 7? So, iba na yung form. So, mangyari, this is negative 81 is equal to 7. So, ano yung multiply ko sa 7 para mag negative 81 siya? So, ito isipin mo, no? Sir, i-multiply ko po sa negative 11. So, kung 7 times negative 11, that is negative 7 to 7. Kulang pa tayo ng negative 4. Eh, wala tayong remainder. So, kung napansin mo, yung form natin is plus r. So, bawal ka magkaroon ng plus negative 11 kasi wala namang remainder na negative. Okay, so note na wala dapat remainder na negative. So, ibig sabihin, kung kulang yung 7 times negative 11 kasi negative 7 to 7 yun, what if sobrahan natin? So, ang gawin natin, 7 times negative 12. Yun yung gagawin natin. So, in that case, magiging 7 times negative 12. Okay, then sobra na yan. So, kung i-check nyo, that is 8 times negative 12. Okay, so, I think, 7 times negative 12. Okay, that is negative 84. So, meaning sobra ng 3. Since negative 84 to, kulang to ng plus 3. So, positive pa rin yung remainder. So, yun yung kagandahan pag sinobrahan mo. So, therefore, 0 is less than equal sa 3, less than 7 lang. Kasi wala naman, hindi naman siya negative. Okay, so where Q dito. So, ang Q natin dito is negative 12. Yung remainder natin dito is 3. So, napansin mo, napakalaking epekto kung saan ko dinadala yung negative sign na yan. Okay, so let's have more example. So, again corollary number 6 yung ginamit ko dito. Pag negative na yung A, corollary number 6. Okay, so next is, for any integers A and B, we have, nabasa ko na yun, sorry. So, consider B is equal to 82, negative 82, A is equal to 14, and negative 14. So, may apat na combination tayo dyan. Una is 82 over 14. So, una is napakadali. 82 over 14. So, yung equivalent nito, so let's say yun yung una, A. Yung equivalent nyan is, that is 5.87. So, meaning, ang equivalent nito is 82 is equal to 14. Huwag kalimutan lagay dito si A. Tapos, 5. Okay, so, ano yung kulang dyan? So, 14 times 5, that is 70. So, kulang ng plus 14. 14 times 5, that is 70. Kulang ng plus 12. Okay, so this is plus 12. Where 0 is less than or equal sa 12, less than sa 14. So, kung napansin nyo, nasa-satisfy niya pa. Yung remainder nakuha ko, mas mababa pa dun sa A ko. Okay, so ano yung Q dito? Q dito is 5 or dito is 12. So, box na siya riyan. Ayan na yung sagot. So, ganito siya kadali. Letter B. So, what if meron kang 82, i-pair ko sa negative 14. So, this is simply 82 pa rin is equal to negative 14. So, kagaya nung kanina, pag yung negative nyo sa ilang, multiply natin sa negative. Gaya lang natin negative to. So, this is negative 5 plus 12 pa rin. This is 0 less than or equal sa 12 less than absolute value ng negative 14 kasi nagbago na siya. Okay, then Q natin dito. Q is negative 5 or is 12 pa rin. Okay, then box lang na siya. So, huwag kalimutan sa may restriction. Okay, so for letter C, yung next combination is negative 82 over 14. So, this is negative 82 which is equal sa kagaya ng kanina doon. So, what if diba ito yung 14? So, kung napansin nyo, minumultiply natin siya kanina sa 5. Yun, what if sobrahan na natin siya? So, i-multiply na natin siya sa negative 6. So, kunyari, 14 times negative 6. That is negative 84. Okay, so, i-multiply ko na siya sa negative 6. Parang i-add ko na lang is plus 2. Okay, so therefore, 0 is less than or equal sa 2 less than 14. Okay, where Q, again, Q is equal to negative 6 or is 2. Okay, so box lang ni sir yan. Ito yung magiging sagot. Okay, next is letter D. So for letter D, negative 82 divided by negative 14. So ayan, napakita ko at least lahat ng possible combination na gagawin nyo. So if you have negative 82 dito is equal to negative 14. Okay, so kung napansin nyo, negative 14 siya. So since negative 82, possible na positive 6 na lang kasi negative 84 na to. Okay, then plus 2, negative 82 pa rin yan. Okay, into which na 0 is less than or equal sa 2 less than absolute value of negative 14. So Q here is ano yung Q? Q is 6 or is 2. Okay, then box lang natin. Ito na yung magiging sagot niya. Okay, so napakadali ni division algorithm. Okay, so hoping nakita mo yung mga idea anong gagawin mo pag parehas positive, negative yung ilalim, negative yung numerator, tas parehas negative. So tingnan niyo mabuti yung diskarte. So again, pag negative na yung numerator, lakihan mo na, sobrahan mo na yun. So from 5, taasan mo na ng isa. Then pag gano'n naman, parehas negative, negative to, tas positive lang yun. Taasan mo yun, negative, pasigay mo lang positive, tapos A na siya. And then wag kalimutan ilagay itong mga restriction kasi ito rin yung hahanapin ko. Okay, so let's have more proving problems pa. Okay, so sabi, show that the square of an odd integer has the form 8q plus 1. Okay, so kung napansin mo ang assumption, square of odd integer has the form of 8q plus 1. So for the proof, ang gagawin natin, okay, for the proof, so ang gagawin ko, maglilat ako ng n. So let n be an odd integer. Okay, so ito yung mangyayari. Kunyari, ang pinili mo, since alam natin na yung odd integer, ang usually natin pinipili pag odd integer is ganito. Kunyari, n is odd. Ang possible piliin mo is si 2k plus 1 or si 2k minus 1. Pero ito yung mangyayari. Once ganyan ang ginawa ko, pinili ko si 2k plus 1 saka si 2k minus 1. Ito nangyari. Pag ni-raise ko siya, kasi i-square ko siya eh. So pag in-square ko siya, that is 4k squared minus 4k plus 1 lang. Dito rin ganun din. Okay, so ano mangyayari? Ang mangyayari is, marireduce lang niya hanggang 4. So hindi ko makukuha yung form na 8. Okay, so ngayon, what if palit lang ko konti in which i-represent ko siya. So dapat, pag nag-represent ka dito ng pagiging odd or even, pwede mong i-adjust konti in such a way na odd pa rin siya. Tulad nito, kunyari, ang in-adjust ko, so kunyari, ang nilet ko, so such that, lagay ko dito, such that n can be equal sa 4k plus 1 or 4k plus 3. So this is for some k element of integers. So check natin. Ito ba ay add pa rin? Yes, add pa rin yan. So kung napapansin nyo, since add pa rin yan, kaya kong gawa ng paraan yan. Okay, so at the same time, mas madali siyang gawin. So ngayon, ang gagawin natin, i-square ko siya. So ulit ko lang, pag in-square ko yung 4k plus 1, that is 16 squared. 16k squared. So may possibility makapaglabas ako ng 8 kasi habol ko 8 eh. Okay, ayun yung mga habol ko dito. Kailangan magkaroon dito ng 8 tapos may plus 1. So kasi ayun yung form na gusto ko mangyari. Okay, so it's either sa dalawa piliin ko. Let's say ito na yung pinili ko. So consider natin si n squared. So consider n squared. So that is equal sa 4k plus 1 raised sa 2. Okay, into which this is equal sa 16k squared plus 8k plus 1. Okay, so kung napapansin mo, pwede ako mag-factor out dito ng 8 kasi 8k plus 1 yung habol ko. So this is equal sa 8 tapos 2k. So this is 2k squared plus k then plus 1. Okay, then iset lang natin or let lang natin or set lang natin na q is equal to 2k squared plus k. So therefore, yung n squared natin is in the form 8q plus 1. So this is done. So nakuha ko yung form. So again, tignan mo muna yung form na pupuntahan bago ka mag-declare ng variable. So at the same time, pag dineclare mo, hindi basta-basta kunyari, gusto ko ganito para lang makuha. Hindi ganun. Siyempre, tulad na ito, yung dineclare ko, yung 4k plus 1 na yan, saka, or yung 4k plus 3 na yan, integer, add integer pa rin yan. Kahit ano ipalit ko na k dyan, add integer kakalabasan yan. Bakit? Even plus add, so kasi even yan eh. Even plus add is always add. Okay, so andyan pa rin si 1, si next. Andyan si 1, si negative 1, si negative 3, si 3, si 5, si 7, si 9. Ano dyan pa rin, kaya kong kunin yan. So hanap lang ako ng value ng k tapos makukuha ko niyan. Okay, so tandaan yung mga scenario ganyan. Okay, next is para last natin, show that if a is an integer, so meaning integer lang siya, wala akong ibang sinabi. So if a is an integer not divisible by 2 or 3, then 24 divides n squared plus 23. Okay, so dito medyo kakaiba, no? Yung proof, explain ko muna yung umpisa. Ito yung proof. So proof natin is, let natin na a be an integer. Let a element ng integers. Okay, since a is not divisible by 2. So ano ibig sabihin a is not divisible by 2? So meaning 2 does not divides a or 3 does not divides a. Okay, so dalawa yung nangyari dito, magkasama sila as in a statement. So hindi ko pwedeng piliin si 2k plus 1. So hindi ko pwedeng piliin dito na si a is equal to 2k plus 1 or 2k plus 3 or 2k plus 1. Tama kasi 2 lang eh. So hindi ko pwedeng piliin na siya 2k plus 1. Hindi ko rin pwedeng piliin na siya ay 2k plus 2 or 2k plus 1. Okay, or 3k plus 1, 3k plus 2. Hindi ko pwedeng gawin ganun. Okay, since or, tas dalawa sila. So tingnan nyo ha, a is an integer not divisible by 2 or 3. So paano ko i-represent si a? na hindi divisible by 2 and 3 nang sabay. Kasi pag ginawa ko lang 3k, obviously hindi lang siya divisible by 3. Pag ginawa ko lang 2, hindi siya divisible by 2. Yun lang. So lumalabas yung isang kakataon. So what if ganito ginawa na, sir? So what if ang sinet ko, let's say that A is equal to 6k plus 1 or 6k plus 5. So i-check natin yan. Yung 6k divisible by 2 or 3 or both. Pero nung nag-add ako ng 1, hindi na. Okay? Then yung 6k divisible by 2 or 3. Pero pag nag-add ako ng 5, hindi na. Okay? So sa kahit anong value ng k na ipalit ko dyan, so for some k element of integers, sa kahit anong integers na ilagay ko dyan, yan ay hindi na divisible by 2 or 3. So sure ako dyan. Okay? So ang gagamitin ko na lang is yung 6k plus 1. So consider natin yung 24 n squared plus 23, or consider natin si n squared plus 23. Okay? So ang gagawin ni sir, I think mali ako ng sulat. I think a squared to. Sorry. A squared to a squared. Sorry. A squared. Hindi natin mag-prove. So i-consider natin. So consider si a squared plus 23. So dapat makapagpalabas tayo ng 24 something dyan para masabi natin divisible siya by 24. Okay, so this is a squared is 6k. Yun na yung gagamitin ko. 6k plus 1 squared plus 23. Okay, next is expand natin yan. This is 36k squared plus 12k, I think, then plus 1 plus 23. Okay, then ang gagawin natin is maglalabas tayo dito ng value ng ilan ba yan? 6k, 12k, tama, 12k lang. So ang gagawin na sir dito is maglalabas ako ng value ng 12. So I think simplify ko muna. This is equal sa 36k squared plus 12k plus 24. Okay, so ang gagawin ko is magpa-factor out ako dito ng 12, tapos maglalabas ako dito, may matitira sa kanyang, I think dito lang magpa-factor ng 12. So may matitira sa kanyang 3k squared plus k, then plus 24. Okay, so ang goal kasi natin maging 24 to somewhat. So ngayon, si 3k squared, so ngayon aware tayo na si k is an integer. Tama, for some k element kasi na integer So case 1, what if si k, so kunyari case 1, if k is odd. Okay, so ano yung value ni 3k squared plus k? Okay, so kung si k is odd, so ano mangyari? So let's say na kinuha natin kunyari lang if k is odd. If k is odd, say set natin na si k is equal to 2q plus 1 for some q element of integers. So ano mangyari dito? This is 3 times 2q plus 1 raised to 2 plus k. So this is equal sa 3 times 4q squared plus 4q. Okay, 4q, so 2q plus 1 pa to, sorry, 2q plus 1 pa, then 4q plus 1, then plus 2q plus 1. Okay, pinalitan ko lahat ng value ng k, then that is equal sa 12q squared plus 12q plus 3 plus 2q plus 1. So pag sinimplify natin, so meron 12q squared plus 14q plus 4. So mapapactor out ko si 2. So mangyari that is 6q squared plus 14q plus 4. So napansin mo even siya in this sense kasi may nakamultiply na to sa kanya. Okay, so kung yung k is odd, even siya. Okay, so what if natukunin natin? So dapat pag k is 2, if k is even, so let's say k is equal to 2q, where q, there for some q element ng integers. So cases lang naman, kaya ginanyan ko na. So yung 3k plus 1, so yung 3k squared plus k, that is equal sa 3 times 2q squared plus 2q. So this is equal sa 3 times 4q squared plus 2q. So this is simply 12, no? So this is 12q squared plus 2q, in which lalabas ko yung 2, then this is 6q squared plus q. So another sense, even pa rin siya. So a number multiplied by 2, generalize na yung k plus 1 natin. So yung 3k squared plus k natin is even. Okay, and that is 3k squared plus k is equal to 2c. So for some c element of integers, so sinet ko lang siya as 2c. So balik tayo doon mula sa kanina. So nagkaroon ng subcases somewhere sa proof. So consider ulit yun. So going back to proof, so this is 12 times 2c na. Okay, then plus 24. So this is equal sa 24c plus 24. So in which this is, diba, ito yung a squared plus 23, galing dun sa taas. Okay, mula dyan yan, galing yan dyan. So a squared plus 23 is equal to 24 times c plus 1. So set lang natin na si p is equal to c plus 1. So this is a squared plus 23 is equal to 24p. So for some p, element of integers again. So by definition of divides, 24 divides a squared plus 23. Okay, and that is done. Okay, so ganun siya kahaba. Mukha lang siya maikli pero mahaba. Pero ito naman, ang kagandahan naman dito, hindi siya masyadong kumbaga hindi siya masyadong mahirap kasi technically lang titignan mo lang yung values. Kung mag-set ka rin ng values, dapat ma-imagine mo rin yung pahiwatig niya. So at least nakakita ka na ng cases na ganito. Alam mo na yung gagawin pag not divisible both, ito yung gagawin mo. So multiply mo yung 2 tas 2 saka 3, kaya naging 6k, tas plus 1 or plus 5, isip ka na lang. Okay, so that's all for this video. Okay, so hoping na may natutunan ka. Okay, and thank you for watching.